Welcome back to Wes Explains Best. We are taking on the part 2 of section 1.4, further applications. We got done doing a money problem, and in this money problem, we determined that we had to find the number of nickels, number of quarters, and essentially we have two equations, and when you have two equations with two variables, what you do is a system of equations. Now, I didn't say system of equations in my last video. I didn't say we use substitution, but essentially that's what we did. So if you wanted to put a name to the method we used, it was system of equations by substitution. We have another one here. Two cars will leave the same place at the same time, one east, the other west. The eastbound car averages 40 miles an hour. The westward averages 50 miles an hour. And how many hours will they be 300 miles apart? Okay, now one thing you should identify each time you're dealing with these types of problems is you should identify what are they asking for. So in how many hours is really the key piece of information here. This is going to be our assigned variable. We can call it anything we want. Let's just call it x. So x is pretty standard for variables. So x equals the number of hours. And that is our goal. We want to find the number of hours. In this problem, we wanted to know how many of each did he receive. Okay, so what we did is we assigned a variable x equals number of nickels. Technically, we said y equals number of quarters, but we found quarters in terms of nickels, so we only had one variable here. Now, we should probably set up this problem where we have two different cars. We have one going east. Okay, this one's the east car, and then the much better car, obviously going in a much better direction, west. It's okay, we all make mistakes. West is the better way to go. So the east car. Now let's break this down. Before we get into the equation, you guys might figure this out already, but before we get into the equation, let me just say there's multiple ways to do this problem. This is one way. And I'm going to break it down into kind of steps so you understand the thought process here. So 1 hour, not hours, 1 hour. So after 1 hour, this car is going 40 miles per hour. Okay, so let's go to, I guess let's use purple. So this car is going 40 miles per hour. So we're going to find our distance here. Our distance, okay, this is one of the variables we have. We know that the distance needs to be 300 miles. Okay, we want to know when they get 300 miles apart. So let's find out how far it's going per hour. Again, we want to know in terms of the number of hours. So after 1 hour, this eastbound car goes 40 miles. How do we know this? Well, if it's going 40 miles per hour, we multiply it by 1 hour, and we get 40 miles. What about 2 hours? So now we have 2 hours. How far does it go? Well, if we go 40 miles per hour, now we're going for 2 hours. So in the first hour we go 40, we go another hour, another 40. So now we're 80 miles. Okay, 3 hours. I hope you guys are seeing the pattern here. We're going to go 120 miles, and so on. Okay. Dot, dot, dot. How does this continue? What we're doing each time is we're taking 40, and what are we doing? Well, after 1 hour, we do 40 times 1, 40. 2 hours. Okay, how do we use 40? We don't use 80, we want to use 40. This was the given miles per hour. So how do we use 40 and 2 to get 80? Well, we multiply it. 40 times 2 equals 80. Okay, how do we use 40 in 3 hours to get 120? We multiply 40 times 3. What's changing each time? What's changing is the variable. The variable, it varies, okay? So the 40 stays constant, it's constant rate. But the only thing that's changing is the number of hours. That's our x. Okay, the number of hours is our x. That's the thing that's changing. And we multiply them, 40 miles per hour times number of hours, and that's going to give us our distance for the eastbound car. For eastbound car, whoops. We'll just call it east. Distance for east. Let's do the same thing for west. So if you want to do the same thing, obviously you get it. If you want to fast forward this part, you understand why we got the thing we got for 40 miles per hour. Go ahead and fast forward, no problems there. So we're going to do the same thing though. We have 2 hours and we have 3 hours. Oops, 3 hours. Okay, so after 1 hour, we go 50 miles. Okay, if you're going 50 miles per hour, then we multiply 50 times the number of hours. Okay, then we go another 50 miles an hour, so we're going to go to 100 miles, then 150 miles. Okay, so what are we doing each time? Well, we're taking 50, and the only thing that's changing, that's a constant rate, so the only thing that's changing is the number of hours. And what is representing the number of hours? X. X stays constant for both things, whether you're going at 40 miles an hour, 50 miles an hour, it stays constant, but it changes. We could drive for more time or less time, so that's why it's a variable, okay? This is a variable because we can either do more or less. That's the only thing that's changing. The 40 miles an hour and 50 miles an hour, those are staying constant. The only thing that's changing is the number of hours. And this will tell us the distance. If we do our rate times the time, it will give us our distance. How do I know that? If you want another way to understand that, miles per hour, a rate is equal to the distance divided by time. So if we are looking for time, another way to think of this problem is if we're looking for distance, then we just multiply both sides by time. It'll cancel out on the right, and we're left with time times the rate, which we did, 50 miles an hour, times the number of hours, x equals the distance. Okay, so we got that part. We have our distance for the west, we have our distance for the east. Now, what do we need to know still? Well, we still have this 300 hanging over our heads. What do we do with that? Well, we want to know when these two cars are 300 miles apart from each other. Okay, so how do we do that? Do we say 40x minus 50x? Do we do 40x times 50x? How do we think of this problem? I think it's easy to think of this problem. Let's first consider if the west car was standing still. So let's say he's stationary, and the east car is zooming away at 40 miles an hour, okay? Well, the distance would just be the distance for the east car, okay? If it's just the east car moving, we could easily set 40x equals to 300 and see how long it takes for this car to go, how many hours does this car take to get 300 miles away from this west car, okay? But that's only one car moving with the west being stationary. What happens if this guy is going away at 50 miles an hour and this guy is going away at 40 miles an hour? How do we calculate it then? Well, if they're moving apart from each other, so this one was going by itself in this scenario, so we had 40, but now we also are adding this west car going away at 50 miles an hour. So what do? We are going to add these two values together, these two distances together, and we want to see when that is 300. This is the key to this problem. Okay, if they're moving away from each other, they're moving away faster, so we need to add the two distances together. Okay, if it was stationary, we'd only use the east. Since we're also adding in the west going in the opposite direction, then we add the two together and we have 300. Now, look, we have it in terms of one variable. We have x and x, so we can easily do this problem. They're essentially covering the distance of 90 miles per hour together. So we're going to input. Well, we're going to combine like terms here. So we have this one and this one. We're going to combine. Let me combine it to green. So we'll use green here. So we combine these two. We get 90x equals 300. We divide by 90 to both sides. And what do we get? We get x equals, well, let me get my calculator out. This is not going to be an integer divided by 90. And I get 3.3 repeating. Okay, so I get 3.3 repeating hours. Another way to think of this is 3 1/3 hours. That'd be a good answer, but if we want to find it in terms of minute, we need to know if we have 1/3 of an hour times 60 minutes per hour, this is going to be equal to, this is minutes, this is hours, we would have 20 minutes. So 3 hours and 20 minutes. That's how long it will take these two cars to be 300 miles apart. Hopefully this second example was helpful in understanding how we can relate linear equations to each other. This is kind of like system of equations. The second one wasn't system of equations, but another way to understand how do we apply these mathematical principles into real world situations. Hope you enjoyed the video, and thank you for watching.